Hello, fellow chemists. In this video, we're going to take a look at an introduction to covalent bonding. This is labeled an intermediate video because it assumes you have a basic understanding of Lewis dot structures and then also a basic understanding of ionic and covalent bonds. If you need a review of those topics, I'll put a link in the upper right-hand corner. So covalent bonding is defined as two atoms sharing one or more electrons. It could be two or more atoms sharing one or more electrons. And covalent bonding occurs between non-metals. So when we look at where the covalent bonding is going to occur, it can be between hydrogen, because that's a non-metal, and then all of these elements over here on the right-hand side of the periodic table, because these are all the non-metals. And if you remember, the nonmetals have relatively high electronegativities, and we'll kind of take a look at that as we go through the examples. And I put a little review over here on the side of how many bonds the most common elements that undergo covalent bonding make. So carbon's going to want to make 4 bonds, so I'll put a 4 up there for carbon. And then bromine, chlorine, fluorine, and hydrogen, they all want to make 1 bond. 1 bond. And then hydrogen also wants to make 1 bond. Sulfur and oxygen, they want to make 2 bonds, and nitrogen and phosphorus want to make 3 bonds. And you can see the trend here. Hydrogen wants to make 1 bond, just like all the other elements in group 1 make 1 bond, and then carbon makes 4 bonds, and then everything in group 17 makes 1 bond, group 16 makes 2 bonds, everything in group 15 makes 3 bonds, and then carbon, which is in group 14, would make 4 bonds. So as we talked before, you can kind of tell how many bonds the elements want to make based upon where they're located in the periodic table. And then eventually what we're going to be doing with these covalent compounds is we're going to be making these things called Lewis structures. And if you understand how to do Lewis dot structures, it really helps to make these Lewis structures a little bit easier. So this video is just going to kind of give us a very basic introduction to covalent bonding. So let's take a look at a couple of atoms as examples. And we'll take a look at hydrogen and chlorine. So the examples we'll look at are hydrogen and chlorine, if they were going to bond with each other. So the first thing that we'll do is just take a look at the electron arrangements of these atoms. So hydrogen has an electron arrangement of just 1, because it has 1 electron in its valence shell. And then chlorine has an electron arrangement of 2, 7. So it has a total of 9 electrons, but it has 7 of them in the valence shell. So you can see chlorine's going to want to get 1 more electron to fill its valence shell, and hydrogen's going to try to get 1 more electron to fill its valence shell. And that's why hydrogen wants to make 1 bond, and that's why chlorine wants to make 1 bond. So the next thing that we'll take a look at is, well, how do we draw the dot structures for each one of these? Remember, the dot structures is just represented by the symbol, and then you put a dot around each of the 4 sides for the valence electron. So hydrogen is going to have 1 dot. And then if we take a look at chlorine, chlorine has 7 valence electrons. Put 1 dot on each of the 4 sides until all sides have 1, and then we start to double them up. So we can see for chlorine it has 3 sets here, and these are all sets for the non-bonding electrons. And chlorine only has 1 electron that's going to bond, and hydrogen has 1 electron that's going to bond. So who are they going to bond to? They'll bond with each other. Now this red circle that I'm drawing is showing this is going to be a bond between those 2 electrons, those 2 valence electrons. Now, what kind of bond is it going to form? Well, let's take a look at the electronegativity differences. Well, the electronegativity for hydrogen is 2.2, and the electronegativity for chlorine is 2 or 3.16. Now, if you take the difference between them, you get 0.96, which is less than 1.5, so it's going to be a covalent bond, but it's greater than 0. So that means that these 2 atoms will make a polar covalent bond. which means the electrons will not be evenly shared between the two atoms. Now, to show this, we're going to draw a Lewis structure. The Lewis structure is just you draw the elements, and then for each covalent bond, you draw a line. And you still have to put in the non-bonding electrons for chlorine. So this line here, is a single covalent bond. And that single covalent bond represents two electrons being shared in the molecule, and the two electrons are these two that I have circled in red. So this is an HCl molecule because it's two or more atoms bonded together, and we draw a line here for the covalent bond. You only draw a line to represent covalent bonds, not ionic bonds. All right, so that's an example of HCl and how it would make a covalent bond and how to draw its basic Lewis structure. And it shows you that they would make a polar covalent bond. Let's take a look at one more example. And in this example, we're going to pick two of the same atom to make a bond. And we'll pick two nitrogens. So now if we take a look at nitrogens, nitrogen is element number 7 in a periodic table, and it says that nitrogen is going to want to make 3 bonds. Well, let's see if that kind of works out when we put down the electron arrangement. Well, if we do the electron arrangement for nitrogen, it's going to be 2, comma, and then you go 1, 2, 3, 4, 5, so it should be 2, comma 5. And we have 2 nitrogens, so they're going to be exactly the same. So I'll put down the other electron arrangement, 2, comma 5. And if we draw the dot structures for nitrogens, they're going to have 5 valence electrons, so 5 dots, 1 around each side. That's 4. We have 1 left over, so we'll double a 1 up over here. And then for the other nitrogen, 1, 2, 3, 4, and then double 1 up over there. So each nitrogen has 1 pair of non-bonding electrons. And each nitrogen then also has 3 bonding electrons. So these two can make a bond. These 2 electrons here can make a bond. And these 2 electrons here can make a bond. So you have 3 red circles. Each one of those represents a bond. And you can see that nitrogen wants to make 3 bonds. Now, the electronegativity difference between them is going to be 0 because they both have the exact same electronegativity of 3.44. So nitrogens are going to make a pure covalent bond, meaning the electrons will be shared evenly between the 2 atoms. Then to draw the Lewis structure for this, we'll put 1 nitrogen, then we'll draw 3 lines, and then the other nitrogen, then put in their non-bonding electrons. These 3 lines represent 3 covalent bonds. Each covalent bond represents 2 electrons being shared. So these 3 lines represent a total of 6 electrons being shared. This is called a triple bond. Organic compounds can have single bonds, like we saw in hydrogen and chlorine, double bonds, or, as we see here in this example, triple bonds. All right, that's it for this video. I hope you learned something, and I will see you in the next lesson.